So far, we have gone through the op-amp 3 configurations, that is one with open loop configuration and uh, closed loop configuration with negative feedback and closed loop configuration with positive feedback. These are the three cases we have gone through. And in open loop configuration and with op-amp with positive feedback, the output is plus or minus Vset. We are well aware of it. Then, what is the output of op-amp in case of negative feedback? That is closed loop configuration with negative feedback. I said V output and V minus are neither increasing nor decreasing. They are settling down at particular values. At what values they are settling down? That's what my point of interest, in which I may be applying input at the non-inverting terminal or inverting terminal. Inverting terminals means instead of ground, here we apply the input. Okay, let us have a look at that particular case. So op amp with negative feedback. So there is a feedback from output to inverting terminal and V input. If you take the voltages at inverting and non-inverting terminals, it is V minus and V plus. Okay. So how do we find the output in this particular case? See, first we know that V output is equal to A into V plus minus V minus. Further, V output by A is equal to V plus minus V minus, implies V minus is equal to V plus minus V output by A. Keep it aside. Next, apply KCL at the inverting terminal, inverting input terminal. Okay, if I take the node equation here, what we can write? V minus minus 0 by R2 plus V minus minus V output by R1 is equal to 0. Very simple point. Let us write V minus terms one side and V output terms on the other side. 1 by R2 plus 1 by R1 is equal to V output by R1. But what is V minus from this? It is V plus minus V output by A. It is multiplied with 1 by R2 plus 1 by R1 is equal to V output by R1. Let us bring this R1 to the right hand side. So that, okay, what is V plus, sorry, and V plus and V input are one and the same. Let me take this one so that it will be easy for me. Vi. Even I can bring this R1 directly here in this step. Anyway, one more step I am taking. So Vi minus V output by A into R1 by R2 plus 1 is equal to V output. Let us separate Vi and V output terms. So Vi into 1 plus R1 by R2 is equal to V output into 1 plus 1 by A multiplied with 1 plus R1 by R2. So that I can write the closed loop gain. The what is the ratio of overall output to overall input? That is V output by Vi is equal to 1 plus R2 by R1 whole thing divided by 1 plus 1 by A multiplied with the same term, 1 plus, sorry, R1 by R2. We can write so. Okay, the equation is looking bit complex. Otherwise, V output. If you want to write, you can write even V output also. What is V output? It is 1 plus R1 by R2 by 1 plus 1 by A multiplied with 1 plus R1 by R2 multiplied with VI. Okay, we can write either of the steps. Doesn't matter. Output in terms of input. It is looking very complex. What is this complex equation? Nothing to worry. We'll see that. Now let us take some example for better understanding of the further analysis. Suppose R1 is equal to 10 kilo ohm, R2 is equal to 1 kilo ohm, and okay, let me take these two values. Further, I am taking different cases, like these values are like this, and A is equal to 10 power 4. If that is the case, what is the closed loop gain? It is equal to 1 plus 10k by 1k by 1 plus 1 by 10 power 4 into 1 plus 10k by 1k. It is equal to 11 by 1 plus 11 by 10 power 4. Okay. If you calculate it, you will get its value around 10.987. I'm directly writing it. Or I can write V output is equal to ACL. It is just nothing but V output by VI only. It is 10.987 times VI. I can write. Okay, keep it aside. So it is almost close. Gain is close to 11. And so this is a first case. Second case, I am taking A is equal to 10 power 5. Then what is the closed loop gain? It is equal to directly instead of writing all those things here, instead of this 10 power 4, okay, I will write 10 power 5. Okay, so it is 11 by 1 plus 11 by 10 power 5. Denominator is increasing. Obviously, right, it comes to be around 10.998 like this. Or the gain or V output is equal to 10.998 times VI. It is also much close to 11. Okay, next what I am doing is ideal op amp. Means if A is tending towards infinity, if A is infinity, then what is the closed loop gain? It is 11 by 1 plus 11 by infinity. So anything by infinity, it is 0. So the answer will be 11. Or V output is equal to 11 times VI. Is it not so? It is looking very simple. Instead of writing 10.987 times right gain or 10.998, 11 gain is much simple. Or in other words, what I can write is ACL, right, I will write it in the next page. What is the original equation is ACL is equal to 1 plus R1 by R2 by 1 plus 1 by A into 1 plus R1 by R2. We know that. Now, if A is tending towards infinity, then closed loop gain is equal to 1 plus R1 by R2 by 1 plus 1 by infinity multiplied with 1 plus R1 by R2, simply speaking. So, what is its value? It is simply 1 plus R1 by R2, that is V output by VI. Or I can write V output is equal to 1 plus R1 by R2 into VI. Is it not very simple? The exact equation is like this. If A is approaching towards infinity, then output is given by this equation. Okay. Then what is the advantage? The equation is looking simple and the exact values means the gain if 10 power 4, then yes, open loop gain is 10 power 4, the closed loop gain is 10.987, which is almost close to 11. But the gain equation is looking something like this, which is a bit complex. Formula wise it is looking complex, but the final result is almost close to 11. Gain is 10 power 5 open loop gain, then the closed loop gain is 10.998. It is much close to 11. The exact value and approximate value, there is no much difference. Why to scratch our head on by using such a complex formula? If you look at this is very complex formula. It is the exact formula, I can say. And it is the approximate formula. Approximate formula we are getting by assuming the closed loop gain, sorry, open loop gain as infinity. Is it not so? And the result, why is there is no much difference? Of course, the gain should be high. Instead of taking 10 power 4, 10 power 5, 10 power 6, like that, if I take open loop gain as infinity, the closed loop gain formula looks very simple. Okay. Now, let us consider the same with open loop gain is equal to infinity from the beginning. What I did, I derived everything. After deriving everything, I take some values for open loop gain as 10 power 4, 10 power 5, infinity, etc. Let us take open loop gain is equal to infinity from the beginning itself. Okay, that means the approximate method I am taking. That means the open loop gain is infinite. Then let us take the same circuit. We output. Okay, and of course it is equal to voltage at the non-inverting terminal, and voltage at the inverting terminal is V minus. Okay, done. Then I wrote like V output is equal to A into V plus minus V minus, from which I wrote V minus is equal to V plus minus V output by A. Okay, as A is approaching infinity, V output by A, it becomes 0. So that V minus will approach V plus. What is the value of V minus? See the interesting thing. Okay, V minus is equal to V plus. If A is approaching infinity. Physically, there is no connection between inverting and non-inverting terminal, because input impedance is infinity. But as the gain is approaching infinity, then V minus approaches V plus. This is known as virtual short. Physically, there is no connection between inverting and non-inverting terminal, but physically no connection between inverting and non-inverting terminal due to infinite input impedance. But as the open loop gain is approaching infinity, then V minus means voltage at the inverting terminal approaches voltage at the non-inverting terminal, which is known as virtual short. So physically no connection, but virtually both are at the same potential. It is like short. Both are at the same potential means there is no potential difference, means it is like they are short circuited. Okay, virtually they are, as they are at the same potential, we call them as virtual short. Okay, I will write the definition of virtual short later. Okay, so V minus is equal to V plus. In this example, what is our V plus? It is Vi. Done. Next, what did I do? Here I applied node equation, KCL at inverting input terminal. So what do we get? It is V minus minus 0 by R2. I'm not changing my procedure. I don't want to confuse the students with n number of procedures. Right? The procedure or the methodology I adopt is like universal. 95 to 99% of the problems can be solved with the analysis I do. Right? Same analysis I do. For every problem, you can have a number of methods. You can use KVL, KCL, etc. But as far as op amps are concerned, it is always better to go with Nodal analysis rather than mesh analysis, nothing else. Most of the problems, 99% I can say of the problems you can solve by taking nodal analysis. Okay, so further V minus into 1 by R2 plus 1 by R1 is equal to V output by R1. But what is V minus? It is V plus, that is of course equal to VI. So it is VI. Let us bring R1 to the left hand side or left hand side. So R1 by R2 plus 1, that is equal to V output. Am I not getting the same answer? Or the closed loop gain is equal to V output by VI is equal to 1 plus R1 by R2. Just like that we got this formula. Earlier the procedure is same. I am not changing the procedure. But earlier formula, right, this is called approximate method, and right, procedure is same, but the result is approximate value of the closed loop gain. Exact value of the closed loop gain is given by this one. Okay, 1 plus R1 by R2. Okay, by 1 plus 1 by A into 1 plus R1 by R2, which is looking a bit complex and difficult to remember. But if A is tending towards infinity, just like that you can analyze the things. Okay, here we can observe the concept of virtual short. Okay, anyway, I will write the definition later. And one more thing, this virtual short, as I said, it is conditional. It is not valid in two cases. Right, when it is not valid means if A is not tending towards infinity, then V output by A cannot be taken as 0, means V minus cannot be equal to V plus. So if A is a finite value, that time you have to use the exact method. Okay, so virtual short, there are two places where the virtual short fails, means case 1, right? If A is equal to some 100, then in the same circuit what you can write, V minus is equal to V plus minus V output by 100. You can't approximate V minus to V plus. And what is the maximum possible value of output? The maximum value of the possible output means it may be plus 15 or minus 15. Then what is right, the minimum value of V minus? Then suppose, right, V output, instead of taking V sat or minus V sat, I am rating some 14.9 volt. If that is the case, what is V minus? It is V plus minus 14.9 by 100. It is V plus minus 0.149. You cannot approximate V minus to V plus. Absolutely. Is it not so? I'm not taking plus 15. Plus 15 means op amp becomes, right, it enters into saturation region, becomes unstable system. For an unstable system, I cannot write output is equal to something into input. That's why it should not reach the saturation levels. So this is the idea. If it is a 10 power 4, I can neglect this fraction. 10 power 5, I can neglect this fraction. Infinity, comfortably 14.9 by infinity, it becomes 0. This is the idea. So virtual short cannot be applicable. If A is less, then virtual short cannot be applicable. In that case, what is the closed loop gain? In that case, the closed loop gain means 1 plus R1 by R2 multiplied with 1 plus 1 by A into 1 plus R1 by R2. So it is anyway, after substituting all the values, 11 by 1 plus 11 by 100. It is 11 by 1.11. I can write. It comes to be around 9.99 something. 91. Okay. I'm writing the value approximately. Okay. It's come something close to 10. But if A is tending towards infinity, the gain becomes 11. Is it not so? This is the idea here. Okay, so this value cannot be negligible. 0.149 or 0.15 cannot be neglected here. If gain is less, this is the scenario. Okay, and this is one case. And a second case where you cannot apply virtual short means case 2. where the virtual short fails. Means A is infinity only. My input is 2 volts. That is nothing but V plus, and V minus is here, V output. The op amp has the power supplies of plus 15 and minus 15 volts. Just as an example I am taking. And R1 is equal to 10 kilo ohm and R2 is equal to 1K. Then A is infinity only. A is infinity. Then generally as A is infinity, what do we write for B output? As A is infinity, what do you expect? V minus is equal to V plus, it is equal to 2 volts and virtual short, and V output is equal to 1 plus R1 by R2 into Vi. It is 1 plus 10K by 1K into 2 volts. How much do you get? 22 volts. Is it possible for output to be 22 from a power supply of plus 15 and minus 15? No, not possible. Not possible means what is V output? Which is, I can say here, this value is less than V output maximum. So not possible. So what is possible? V output is equal to plus 15 volts. This is the maximum possible value. So if V minus is equal to V plus, then only output is equal to 22. As 22 is not possible, then V minus is equal to V plus is also not possible. Very simple. So V minus cannot be, which implies V minus cannot be equal to V plus. But V plus is 2 volts, no doubt about it. But V minus cannot be 2 volts. It is something else. What is that value of V minus? Means for that, again, I am redrawing. So V plus is 2 volts only. V minus value I want to find. For finding V minus, what can we do? Apply KCL at the inverting input terminal only. Okay, here what is the value of R1? It is 10K, R2 it is 1K. So apply KCL at inverting input terminal. V minus minus 0 by R1 it is R2 1K plus V minus minus V output 15 by 10K it is equal to 0. Okay. So instead of V output I am writing 15K, instead of R1 R2 I am writing 10K and 1K respectively. Then kilo and kilo I can cancel. V minus plus V minus by 10, it is 10 V minus by, sorry, 11 V minus by 10 is equal to 15 by 10. 10 and 10 cancel. V minus is equal to 15 by 11. How much do you get? 1.36. Okay. 35. 36, sorry. Correct. This is what? Is it not so? What is V plus? And V plus is equal to V input, that is equal to 2 volts. Is it possible to apply virtual short here even though gain is infinity? No. So means if the output of op amp reaches its extreme values, then virtual short fails. you cannot take V minus is equal to V plus. Okay, and here you can see V minus is less than V plus and output is anyway positive. The comparator operation you can look at. Once the output reaches its extreme values, even though A is infinity, you cannot apply virtual short. This is very, very interesting point and important point. Okay, now I am writing the definition of virtual short. Okay, see this. In an op-amp circuit, with closed loop configuration, or an op-amp circuit in closed loop configuration with negative feedback. In closed loop configuration with negative feedback, I am discussing with negative feedback, of course with closed loop configuration. By configuration or an op-amp circuit with negative feedback, anything you can write. Feedback. Even though inverting and non-inverting input terminals are physically separated by large input impedance, large in the sense infinite. Okay, okay, that means Ri is tending towards infinity, even though they are separated by infinite input impedance. As A open loop gain A is approaching infinity, as open loop gain A, let me write open loop gain. A approaches infinity, then right, V minus is equal to V plus minus V output by A, that A is tending towards infinity, means V minus is equal to V plus. Okay, I can write as A is approaching infinity, then V minus approaches V plus. Right, in brackets I wrote it, this statement, how it is so. So as A is approaching infinity, V minus approaches V plus, and that which is known as virtual short. Physically no connection, but V minus is equal to V plus, which is known as virtual short. Okay, which is applicable as long as, right, known as virtual short, which is applicable, I am writing here, which is applicable as long as minus V saturation less than V output less than plus V saturation. The output should not reach its extreme values. Okay, A is approaching infinity, right? And if A is finite, you cannot apply virtual short. We have to go with exact method. If A is finite, if open loop gain A is finite, we should follow exact method. That's it. I hope you understand the point. Okay, A should be infinity, then only V minus will approach V plus. Okay, and both are equal means that is known as virtual short. Physically no connection at all, but both are equal. If A is approaching infinity, that is known as virtual short, which is applicable if and only if output is not reaching its extreme values. If output reaches its extreme values, then V minus is not equal to V plus. That's what we can understand from the example we have analyzed here. Okay. And one more thing. What do we call this circuit? We call this circuit as a non-inverting amplifier. Why it is named as amplifier? The gain is more than 1. Okay. So the gain is right greater than 1, and you can take greater than or equal to also. Okay, let it be greater than 1. It's providing some gain, and output is in phase with input. Input is positive, output is positive, input is negative, output is negative. No inversion between input and output. So this circuit is known as non-inverting amplifier. Okay, I can call this circuit here. I will write it otherwise. This circuit is called, above circuit is known as non-inverting amplifier. Okay, this is the idea here. Next, instead of giving input at the non-inverting terminal, let us apply input at the inverting terminal. Analyze the same. Okay, exact method and approximate method, both I will take. And we call that as inverting amplifier, of course. Okay, I'm just writing the title first. Later I will explain why the name inverting amplifier. So the non-inverting terminal is connected to ground, and we apply input to the inverting terminal. Oh, sorry. R2 output. Anyway, it has the power supplies VCC and minus VCC. No doubt about it. Power supplies are must, without which it won't work at all. Then, as usual, how to find V output? So, if you look at the previous case, sorry, yes, one more point. I said here the output is neither increasing nor decreasing. It is settling down at a particular value. At what value it is settling down? If A is approaching infinity, output is settling down at a value given by 1 plus R1 by R2 into Vi. At that value, output is settling. And at what value the inverting terminal is settling? The inverting terminal is settling at a voltage equal to voltage at the non-inverting terminal. Is it fine? So earlier we were not know the output and voltage at the inverting terminal are neither increasing nor decreasing. They are settling at certain values. At what values they are settling down? Means voltage at the inverting terminal is settling at the voltage at the non-inverting terminal, the first point, and output is settling at a value given by 1 plus R1 by R2 into voltage at the inverting or non-inverting terminal. In this example, it is Vi. That's it. Okay. Similarly, the second case I am taking, that is inverting amplifier. The procedure remains the same. It does not change. Means I wrote here V output is equal to A into V plus minus V minus. Okay. And from which I wrote V minus is equal to V plus minus V output by A. Okay. In this particular example, what is V plus, friends? It is V plus and it is V minus. V plus is 0. It is 0 minus V output by A. Keep it aside. Next, what did I do? Apply KCL at the inverting input. Then what do we get? it is V minus not 0, it is Vi by R2 plus V minus V output by R1 is equal to 0. Okay, let us separate V minus terms, that is V minus into 1 by R2 plus 1 by R1 is equal to Vi by R2 plus V output by R1. But what is V minus? It is equal to minus V output by A into 1 by R2 plus 1 by R1 is equal to Vi by R2 plus V output by R1. Okay, let us bring R1 to the left hand side. This R1 I am bringing to the left hand side, or multiply both sides with R1, simply speaking. So minus V output by A into R1 by R2 plus 1 is equal to R1 by R2 into Vi plus V output. Let us separate V output and Vi terms. That means V output into 1 plus 1 by A into 1 plus R1 by R2. It is equal to minus R1 by R2 into Vi. Or I can write V output is equal to minus R1 by R2 by 1 plus 1 by A into 1 plus R1 by R2 times Vi. Okay, the denominator remains the same. Earlier case, in the numerator we got 1 plus R1 by R2. Now we are getting minus R1 by R2 in the numerator. And what about the closed loop gain? The closed loop gain is equal to V output by Vi. It is minus R1 by R2 by 1 plus 1 by A into 1 plus R1 by R2. That's it. Okay, this formula is looking really horrible. And the analysis, anyway, simple nodal analysis only, but the equations are looking a bit clumsy and difficult, looks like difficult to remember. That's why, for better understanding, for better conclusions, what we do, we take some numerical values. Suppose, right, I am taking R1 is equal to some 10 kilo ohm and R2 is equal to 1K with A is equal to 10 power 4. Then what is our closed loop gain? It is minus 10K by 1K by 1 plus 1 by 10 power 4 into 1 plus 10K by 1K. So how much do you get? Minus 10 by 1 plus 11 by 10 power 4. Okay. So if you take it, it is minus 9.98 something, you get it. 989. Okay. Then suppose, which means, or I can write, or V output is equal to minus 9.989 times Vi. Okay. Right. We can write like this. And A is equal to, suppose A is equal to 10 power 5. Then what about the closed loop gain? Just here I am substituting. Just instead of this, what we can write? Minus 10 by 1 plus 11 by 10 power 5. So if you take it, it comes to be around minus 9.998. Okay, much close to minus 10. These are values are closing to, or suppose A is tending towards infinity, then what is the closed loop gain? Minus 10 by 1 plus 11 by infinity, its value is equal to minus 10. So there is no much difference among these three values, but the equations are looking very tough. Or I can write the closed loop gain is equal to minus R1 by R2 by 1 plus 1 by A is infinity into 1 plus R1 by R2. That is equal to minus R1 by R2. So there is no difference among all the values, the final results, but there is a huge difference in the formula. Is it not so? That's it. And this is called approximate value. This is approximate. And these are exact values. These two are exact values. Okay. Again, right, instead of analyzing everything and assuming gain is equal to open loop gain is equal to infinity at the end, let us take the value of open loop gain as infinity from the beginning itself. That is called approximate method. Okay, so now it is V plus and it is V minus. We know that V minus is equal to V plus minus V output by A. So approximate method means the open loop gain is approaching towards infinity. As open loop gain is approaching infinity, V minus approaches V plus. What is V plus in this example, friends? 0. Okay. Further, apply KCL at inverting input terminal. So what do we get? V minus minus Vi by R2 plus V minus minus V output by R1 is equal to 0. And V minus into 1 by R2 plus 1 by R1 is equal to Vi by R2 plus V output by R1. We can write it so. What is V minus, friends? It is 0. Okay. Is it not so? Or I can write directly 0. Right? Instead of doing this much, a much better way to do it. Much better way to do this is, anyway, the procedure is same. Right? Right. This is a bit lengthy, not required. So apply, right, V minus is equal to 0. So KCL at inverting input terminals, instead of V minus I am writing 0. 0 minus Vi by R2 plus 0 minus V output by R1 is equal to 0. Or V output is equal to minus R1 by R2 into Vi, or the closed loop gain V output by Vi is equal to minus R1 by R2. How simple we are able to write the result. Okay, virtual short we have applied. Later simply take the node equation at the inverting terminal, we got the result. Even previously also the same thing, approximate method, what I did here, non-inverting amplifier, approximate method, applied virtual short. Okay, then take the apply KVL at the KCL at the inverting input terminal. Over. Just like that we got the result. Okay, that's it. Instead of V minus, you can write even V input. Vi minus 0 by R2 plus Vi minus V output by R1. Directly you can write V output is equal to 1 plus R1 by R2 into Vi. That's it. It's as simple as that. The same procedure. I'm not changing the procedures at all. The exact formula and approximate formula, you see how simple they are. The advantage of open loop gain being infinity. Okay. Earlier, when I started the op-amps, when open loop gain is infinity, the transfer characteristics are something like this. Output versus VD. Then what do we do with this? Nothing else. Now you can see the excellence. Okay, just like that we can derive the relation between output and input in the closed loop configuration with very simple method. Okay, and again, when will this approximation, and here one more point I can say, virtual ground and virtual short not one and the same. Earlier one I said virtual short. Here I can say virtual ground. To be frank, the inverting terminal is physically not connected to ground, but as its value is 0, voltage at the inverting terminal is 0, this is known as virtual ground. Okay, in the inverting terminal, right, in the inverting amplifier, as the non-inverting terminal is at ground potential, virtually inverting terminal is also at ground potential, and hence this circuit right here, it is inverting terminal is said to be virtually at ground potential. Okay, right. In the case of, right, in an inverting amplifier, virtual short is right, its virtual ground is a special case of virtual short, I can say. In an inverting amplifier, okay, if non-inverting terminal is connected to ground, okay, as if a is approaching towards infinity, then v minus is equal to v plus is equal to 0, means that is inverting terminal is virtually at ground potential, that is inverting input terminal is virtually at ground potential. Okay, everywhere virtual short we can use default, and virtual ground is a special case of virtual short. Virtual ground is a special case of virtual short. That's it. Okay, and again, virtual ground or virtual short, it is conditional, right? It, when will it fail? Means Vi is not very large, then virtual ground fails. Virtual ground or virtual short fails. Suppose the open loop gain A is equal to 100. Then what about the closed loop gain? It is minus R1 by R2 by 1 plus 1 by A into 1 plus R1 by R2. So it is minus 10k by 1k by 1 plus 1 by 100 into 1 plus 10k by 1k. That is minus 10 by 1 plus 11 by 100. Minus 10 by 1.11. Okay, how much do we get? Means its value is going to be minus 9.009, or approximately I can say minus 9. Closed loop gain means you have to use the exact formula only. You cannot use approximate formula. Next, what about V minus? It is V plus minus V output by A. Suppose that I'm not taking, I'm taking the extreme values of the output. Suppose my output is equal to something like plus 15 volts or minus, not 50, plus or minus 15 I cannot take. I can take here around 14.9 volt, less than V saturation, and V minus is equal to V plus minus 14.9 by 100. It is V plus minus 0.149. So I cannot take V minus is approaching towards V plus. There is a difference. So virtual short cannot be applicable. That is, virtual short cannot be applicable. Or V plus is 0, no? Anyway, V plus is 0. It all depends. Or if, right, as I have written here minus 10, minus 9, etc. closed loop gain. Okay, I can take minus V output is equal to minus 14.9. Anything you can write it, right? Suppose V output is, then what happens? It is minus, then it is plus and plus. Very simple. However you write it. So is it possible to say 0.15 is equal to 0? No, you cannot. So virtual short fails. This is the interesting part here. Okay. So next, there is another case. A is infinity, but I am taking, right, let me write here also. Case 1, case 2. Earlier I wrote, no? Case 1. Case 2. A is approaching infinity, but in this non-inverting terminal is connected to ground, plus 15 and minus 15 volts V output. Okay, as A is approaching infinity, what we write? Okay, V minus is equal to V plus minus V output by A. As A is approaching infinity, it is V plus whose value is 0. And the gain is equal to, implies the closed loop gain or V output, right? Anyway, my input is something like 2 volts. Okay, then what do you expect? Okay, so closed loop gain is equal to minus R1 is equal to 10k and R2 is equal to 1k. It is minus 10. That's what we expect. Okay, and V output is equal to minus 10 into Vi minus 10 into 2 minus 20 volts, which is less than V output minimum. Is it possible? What is V output minimum? Minus 15 volts. It is not possible. So what is possible then? V output is equal to minus 15 volts. That is possible. As V output is minus 15, then, right, if V minus is equal to V plus, then output is minus 20. Minus 20 is not possible, means V minus cannot be equal to V plus, it is something else. Okay, implies V minus cannot be equal to V plus. Virtual short is failing. As the output is reaching its exceeding its extreme values, virtual short automatically fails. Then what might be the value of V minus? For that, again, we can redraw the circuit and apply the node equation. V output is equal to minus 15 volts, R1 is equal to 10k, and input is 2 volts, R2 is equal to 1k, and it is V minus. How do we find V minus? KCL at inverting input terminal. Okay, so what do we get? It is V minus minus 2 by 1k plus V minus minus of minus 15 by 10k is equal to 0. Kilo kilo cancel. Then 11V minus by 10 is equal to 2 minus 15 by 10. So it is 20 minus 5 by 10. So V minus is equal to 5 by 11. It is equal to 0.45 volt. And V minus is equal to 0.45 and V plus is equal to 0. Are they equal? No. And one thing you can see, now you can see, look at the comparator principle. Voltage at the inverting terminal is 0.45 volt and voltage at the non-inverting terminal is 0. So inverting terminal voltage is dominating the non-inverting terminal voltage. So output is minus V saturation. Absolutely, that is valid. You will not get V minus to be negative here as far as this example is concerned. Okay, so virtual short fails even though gain is infinity. Open loop gain is infinity. Okay, it's all possible. It all depends upon, you cannot give any input of your choice. There is a limitation on the input. So when can you apply the input here? How long you can apply the input? As long as the output is not reaching its extreme values, within that range only you can vary the input. Once the output is reaching its extreme values, then for that particular value of input onwards, virtual short automatically fails. System becomes non-linear. Okay, you cannot write output is equal to something into input. You can write V output is equal to minus R1 by R2 into Vi as long as output is not reaching plus or minus V. That's it. Okay. So linear system, you are writing V output is equal to something into input, maybe inverting or non-inverting amplifier. Okay. Then why the name inverting amplifier? You can see, right, if you look at this particular circuit, what is the gain? Negative. Our output is equal to minus R1 by R2 into Vi. Input is positive, output is negative, input is negative, output is positive. It is providing some gain of gain magnitude of R1 by R2. But the negative sign indicates that output is 180 degrees out of phase with input. So there is an inversion of the input signal. That's why the name inverting amplifier. Along with the gain, it is providing a phase shift of 180 degrees and hence we call this amplifier circuit as inverting amplifier circuit. In an inverting amplifier, you can say virtual ground. Of course, the non-inverting terminal should be connected to ground. That time you can say virtual ground, which is a special case of virtual short. You can say everywhere virtual short. Of course, as long as the output is not reaching its extreme values with negative feedback, inverting terminal voltage is equal to non-inverting terminal voltage, then I can say virtual short. But virtual ground is a special case of virtual short. Please do remember this point. Virtual short is conditional. Okay. And inverting and non-inverting terminals. The next circuit, I can say voltage follower. Here, what do we do? Simply shorting the inverting terminal and output voltage. No resistors. Here we are giving input and output. So the inverting terminal voltage and output are equal and non-inverting terminal voltage and input are equal. Okay. We know that V output is equal to A into V plus minus V minus. Here there is no node. Where can you apply KCL, etc.? You can't. But okay, then further I can write it like, so that directly I am using this statement. This statement I have been writing every time, but at the very beginning. V plus is equal to Vi and V minus is equal to V output. So V output into 1 plus A is equal to A into Vi. Then the closed loop gain is equal to V output by Vi is equal to A by 1 plus A. That's it. Then if A is extremely high, then what happens? Suppose, okay, or V output is equal to A by 1 plus A into Vi. Anything we can write it, not nothing to worry about it. Or just okay, why? V output is equal to A by 1 plus A into Vi, or the closed loop gain is equal to V output by Vi is equal to A by 1 plus A. Suppose A is equal to 10 power 4, then closed loop gain is equal to 10 power 4 by 1 plus 10 power 4. Is it necessary to scratch our head with this value? Nothing to worry. It is around 0.9998 something you will get it. Such a huge value. Or close to 1. 10 power 4 by 10,000 by 10,001. It's close to 1. Nothing to worry about it. So voltage follower or buffer amplifier. Voltage follower or buffer amplifier, what is the gain? 1. We are well aware. Yes, absolutely you are getting. Or if A is tending towards infinity, don't substitute here. If A is tending towards infinity, infinity by infinity, you will get it. So you will be in trouble. So we know how to manipulate the things. Mathematics. We are good in mathematics. What I can write? ACL is equal to A by 1 plus A. Let us take A from the denominator outside. So A cancel. It is 1 by 1 plus 1 by A. This is what I have been doing every time. Right, A is tending towards infinity means I am bringing A in the denominator rather than keeping it in the numerator. As A is coming, so if A is open loop gain is approaching infinity, then the closed loop gain is 1 by 1 plus 1 by infinity. 1 by infinity, it is 0. So 1 by 1 plus 0, it is 1. Absolutely. That's it's all about how you make the things simple. Okay. That's it. That's why I follow this approach. Okay. A is infinity. Hence the name voltage follower or right buffer amplifier or virtual short. Virtual short means if A is approaching infinity, then voltage at the inverting terminal approaches voltage at non-inverting terminal. So V minus is equal to V plus is equal to 0. And of course V output and inverting terminal are shorted, so V output is equal to V minus, which is equal to V plus, which is equal to Vi. Very simple. Nothing to apply any KCL, KVL, etc. Okay, this is the idea here. So you can write this one. Okay, so or approximate method, I need not write it. Okay, due to virtual short, you can write it. Approximate method not required actually for this circuit. So it is equal to V plus and V minus is equal to V output. So what you can write, V output is equal to V minus and which is equal to V plus, which is equal to V input. As A is approaching infinity, V minus is equal to V plus, or the closed loop gain okay, voltage follower, or I can write it as buffer amplifier. It's as simple as that. Okay, we have gone through three kinds of amplifiers: non-inverting amplifier, inverting amplifier, and voltage follower or buffer amplifier using op-amp. The same three circuits we have gone through using BJT and FET. Now let us have a look at this table. See, gains of different amplifier circuits, amplifiers. Inverting amplifier using BJT. What is that? CE amplifier, whose gain is minus GM into RO. Of course, GM is equal to IC by VT. Eta VT also, we can write it IC by VT as far as BJT. And the same inverting amplifier using FET means it is common source amplifier. Source is similar to the emitter of BJT. Source of FET is similar to the emitter of BJT. So where the gain is given by minus GM. What is GM here? Anyway, right, we have formulas for GM and all, right, nothing to worry about it. We have already studied these things. And op amp, right, here also the gain, inverting amplifier, the gain is minus R1 by R2. Okay, I'm not writing the circuits of CE amplifier, CS amplifier, and op amp circuits. We know the circuits. Non-inverting amplifier, common base amplifier, whose gain is GMRO, and common gate amplifier using FET, whose gain is GMRO, and op amp means 1 plus R1 by R2. There is a slight difference. Magnitude is almost similar, almost equal. To be frank, even with BJT and FET also, the gains of CB and CG amplifiers are slightly greater than CE amplifier and CS amplifier respectively. Next, voltage follower or buffer amplifier using FET, using BJT means CC amplifier whose gain is 1, and FET means common drain amplifier whose gain is 1, with op amp buffer amplifier whose gain is directly 1 we have gone through. Okay, so we have studied already BJT and FET circuits. Now with op amp, you can see inverting, non-inverting amplifiers and voltage follower. That's it. Okay, next we will see the various circuits of inverting, non-inverting amplifier circuits further. right? How many ways we can have different circuits. So now onwards, what I do is I just follow the approximate method. Means whenever I see an op-amp circuit, why? Okay, I will simply apply virtual short. After applying virtual short, simply take the node equation at the inverting input terminal. Immediately, you will get output equation or the gain equation. Whether it is non-inverting amplifier or inverting amplifier or voltage follower, no, it doesn't require any node equation. Okay, so I just follow this method. Any op-amp circuit, simply apply virtual short. After that, take the node equation at the inverting terminal. Simply you will get V output equation or the gain equation. That's it. Okay, let us solve some problems in the next section.